Okay, hello guys. Today I'll talk about the arcs and sectors, okay? So let's move into the first part about arcs and sectors, okay? So what is a sector? You can find here, I'll give you a graph. So you can find here, a sector is like a pizza slice of a circle, okay? So because that is defined by the radius r and the central angle theta, okay? So we have two kind of sectors. First is minor sector, okay? Which means the angle theta is smaller than 180 degree, okay? Another is called major sectors. Okay, so the sector means the angle theta bigger than 180 degree. Okay, so that there is the two different types of the sectors. Okay, so they're very important in us to understanding for sectors. Okay, so another is called the arc length formula. Okay, so we knew that for the total perimeter for a circle, we can set here. For a circle is like this is a circle and this is a radius, right? And we said last lesson that the perimeter equals to 2 times pi times the radius, right? Okay. So here, if we only choose a sector or some part of the circle, we can find here that is a sector and the angle here is theta, okay? So you can just consider that there's a pi, right? You can just maybe it is Saturday and you and your friend are enjoying a pie. And here you can say the theta means the theta takes place the total 360 degrees. So when you take this pizza or like the pie away, that it takes about theta over 360 of a total pies, right? So here you can say, or maybe for the perimeter right here, that equals to theta over 360 means the part or the partial number of the total circle, okay? 10 times the perimeter, 2 pi, okay? So it means this arc length, okay? So we can call this as the arc length formula, okay? So here's an example, like here, we have the radius equals to 6 centimeter and the theta equals 60 degree, and we can use in the formula like 60 degree over total angle that is 360 degree, and then times 2 pi times the radius, okay? So 2 pi times the radius is 6, okay? So we can set the length here as 1 over 6 times 12 pi. Finally, it equals to 2 pi, okay? So we can let pi equals to 3.14, right? And we put in it, that is 2 times 3.14, that is 6.28 centimeter, okay? That is arc length right here, okay? And another sector area formula like here is the area sector. Okay, so we can say like here the angle is theta and total degree is 360 degree. Okay, so we can say that this sector takes place about 6 theta over 360 pieces in the total circle. Okay, so we knew that the circle's formula or the area's formula for a circle is pi r squared, right? So you can just times theta over 360 times pi r squared. Okay, that is the formula. Okay, so we can say that this formula we can consider as a fraction times a total circle. Okay, that is the sector area. And we also have the total perimeter of a sector. Okay, so you can find here, perimeter for a sector, we have a radius 1, a radius 2, and an arc here. Okay, so we can say here that is arc plus 2 times the radius. Okay, that is a perimeter of a sector. Okay. And also we have the area of a segment, and we can say here the area of a segment equals to the area of a sector minus the area of a triangle. Okay, so maybe here you can just using the formula that is area of a triangle equals to a half times radius square or two sides square. Okay, maybe here that is a two side, that is side 1, side 2, they times together, then times the sine theta, then times a half. Okay, that is the area of a sector. So if you just consider here this is a triangle and total sector it is like theta over 360 degrees and times pi r squared, right? Okay, so we can say after we delete the area of a triangle, that is the area of a segment. That means here, this is the area of a segment, okay? This is called segment, okay? So this is how to find the area of it, okay? And here are some deliberate practice for you. If you want to try on yourself, you can pause the video and then just do it yourself. But if you want to follow with me, you can keep on going, okay? So for the first problem, it said the sector has a radius of 8 centimeter and angle 45 degree. Calculate the arc length, right? So you can try to draw the arc at the first time, okay? That is angle here. And we can say angle equals to 45 degree. And the radius is 8 centimeter, right? So the arc length, we can say that is theta over 360 degree times 2 pi radius, right? So see that here equals to 45 degrees. So 45 over 360 degrees, that is for, I guess, is 1 over 8, right? So this is 8. So 2 pi r, r radius here is 8, okay? So that is 2 pi times radius 8, and then over the 8, okay? So that is for 2 pi, okay? That is the arc length right here. So if you want to just convert it into the decimal places, we can just consider pi as 3.14. That is 6.28 centimeter, okay? That is for first problem. And for second problem, calculate the area of sector with radius 10 centimeter and angle 120 degree, okay? So we can say here that the area of a sector, we can say that is pi r squared, right? Then times part of the total part, that is 360 degree as our final or total angles, okay? So we can say here radius 10 and this is 1 over 3. So finally, the area here is like 100 pi over 3, okay? That is for second problem. And for third problem, and is that the arc length of a sector is 15 centimeter, and the radius is 6 centimeter, and find the central angle theta, right? So being said here, the radius is 6 centimeter, and the arc length that is here is 15 centimeter, right? So if you want to calculate the central angle theta, you can just try to use like the parameter formula, right? That is like pi 2 pi r, right? That is a total circles parameter and then times the partial, right? That is theta over 360 degree. That is for I guess is 15 centimeter, right? So theta over 360 degree equals to here radius equals to 6 centimeter, right? That is 15 over 12 pi, okay? So we can set theta finally equals to 15 over 12 pi then times 360 degree, and that is for, I guess it's for 4, and here's 90 degree, and here is for 5, that is 450 degree over 3.14, okay? So then you can use a calculator to calculate it, okay? So I think it's a little bit harder for you to calculate this problem, okay? So for the fourth problem is that find the total parameter of a sector with radius r equals to 9 centimeter and the theta equals to 72 degree, right? So here, if you want to calculate the parameter, so that is for 2r, 2 times the radius, and then plus the theta that is 72 degree over 360 degree times 2 pi radius, right? Okay, so 2 times radius equals to 18 centimeter, okay? And 72 over 360 degree equals to 1 over 5. And here radius equals to 9, okay? That is for 18 pi over 5, okay? That is for the fourth problem, okay? And for last problem, we have theta equals 60 degree and radius equals 60 centimeter, okay? So you want to calculate the area for minor segment, okay? That means here, the purple areas for the segment, okay? So you don't need to understanding what is or why is a triangle's area. Why is for a half times 6 squared times sine 60 degree. That is area of triangle. Okay, I'll help you to just try to calculate this. This is for 18 times sine 60 degree equals to square root 3 over 2. Okay, that's 9 times square root 3. Okay, so the like the arcs or sectors area that is for like 60 degree over 360 degree, right? And the times pi are square. Okay, so we can say that the area here is 6 pi, okay? So we can say that the minor segment area here is 6 pi minus 9 times square root 3, okay? That is for the fifth problem, okay? So I hope you can understand it for the first problem to fifth problem. Okay, so they are very classical, and if you just finish them, I believe you can just do a great job and follow, follow the syllabus. Okay, you can truly understand it for this. Okay. So that's for our lesson. See you next time. Bye.